we're going to go to a very exciting topic, something that I've been involved in for the last several years, and something all of you will be involved in. So what we're going to do is I'm going to quickly tell you what we're going to talk about, which is the past of quality. So what is quality, and then what's happened in the past, how it's evolving now nationally and internationally. I'm going to spend most of the time on quality management systems, and we'll talk a little bit about the future of quality in the clinical laboratory. So what was the most important word other than my name that you saw on that slide that was up before? The slide that you all were staring at for many minutes. So the most important word is customer. And in our case, it's patient. So it trumps everything I'm going to say. All quality management systems are aimed at the patient. All improvement processes, and I talked about lean last time I was here, are aimed at the patient, putting them first. And it's an incredibly powerful technique, and it erases a lot of controversy when you say, what's the patient want? And it changes really the way that you think about the clinical laboratory. So that's the first piece of quality, is aimed at the customer, and you'll see that theme come up time and time again. There will be other themes that are hidden in this talk, and there'll be a quiz at the end, and so we'll see who gets those themes. So quality does have a history. In medieval times, you picked out the best blacksmith in town or the best baker in town. You went on past that, there was really you had this period of artisans and guilds, and if you look at that, you realize that's our residency training program, right? That's really how we still do things, with a guild with some apprentices and journeymen. And then you move into inspectors and then organizations that certify you for your quality. As factories came aboard, we moved away from that type of certification more toward mass production and really having to look at quality in a different fashion. And scientific management of quality came in the early 30s and then blossomed in the US in World War II and after that. It became even more and more scientific. As manufacturing went global, there was a need to be able for us in Seattle, if we were going to buy a part for an airplane, to know that it was made with some quality without having to send 3 of our engineers to some factory in, let's say, Italy to check it out. And so then came some standards for quality that were international in manufacturing, and those standards came from an organization called the International Standards Organization. The same people that have a stamp on the tires of your car, for example, to show that they're made to some specification. The clinical laboratory has evolved similarly, but much behind the quality in manufacturing. So if you go back to the canons of medicine, there's not a word about quality in the examination of the urine in Persia. In 1948, in a book loaned to me by Joanne Simpson, there's no mention of quality in Todd and Sanford. Interestingly, the CAP started up their accreditation program in the 60s, but in spite of that, in Paul Stranger's copy of Todd and Sanford, there is no mention of quality, at least as a chapter. Westgard, who many of you know, really started publishing about quality in the 70s and has kept on and on and on and on, much to our benefit. Dr. Rainey's edition of Henry's, which I don't know why it's not in his cubicle, but I found it actually in the conference room. There were papers in it that I can't talk about, but it does have a chapter on quality. And then this Wallenstein's book on quality management came out from the CAP just a few years ago. And in 2008, the college certified its first laboratories under the ISO standard 15189. So quality control in the laboratory that we do every day, that we actually take for granted. Years ago, we didn't take it for granted, but now we do take it for granted, is really just a process control. The process is an analytical process. We're looking at the statistics, the variation, and making a decision. Does it look like the assay worked, yes or no? That all began in the 30s and then got transferred to the laboratory with Levy Jennings, who we use for the name of the plot now, in the 50s. But it really wasn't, I think, till Westgard came in with his publications and looking at quality in the laboratory in the 70s that really picked up steam. And with a variety of Westgard rules and books and seminars and people thinking about quality, and that has served us really, really well. In fact, it serves us better than I actually thought. I stole this slide from a webinar the other day. Actually, I went back to the original source. I just want to mention that. Most of my slides are stolen, but this one I went to the original source on. And laboratory medicine is at 5 sigma. We are close to 6 sigma as far as our defects. And that's pretty good, and we have to applaud a lot of people in this room for getting us there. That's the analytical piece of it. And so in some respects, that tells us we're pretty close to where we want to be on the quality that we produce for our analytical quality. And echoing that is a new move by CMS to back off on quality. Now, at least I think that's what this says. I took this from their website, and you can read it, and maybe you guys can decipher it. I had troubles deciphering it. But there is now the provision for us to look at all our quality systems and do less than what CMS requires of us, but not less than what the manufacturer requires. Looks like it's a lot of work to me, but somebody's going to do the cost equation to see if they should do that for some of the assays in their laboratories. So this is actually very similar to childhood oncology, where right now we're backing off on therapy. We're doing really, really well on most tumors, and we're asking the question, can we get by with less? And that's what this is asking. Can we get by? We're pretty good now, or very good. Can we back off a little bit and move forward into some other areas? So process control, quality control, we are pretty close to there. But there's more to quality than just our daily QC. And the way the quality works is pretty much like this. You got quality control at the bottom, and then quality assurance is kind of the next level. That's what you add on to these process controls. And that's things like, say, double verification or double input to verify to get around a manual entry system. And we have lots and lots of those dispersed little islands of mistake proofing, places to make our quality better that is above just our QC data. And we all live those every day. We track down defects and we work on those defects and we try to figure out why they occurred, and we wish they hadn't occurred. The next level up is really taking, in part, those quality assurance activities and combining them into a system. So one analogy, it's a stretch, but you guys can think about this, is total lab automation. Before total lab automation came in with its big monster robots and lines, we had automation all over the lab that just wasn't connected. And it worked pretty well for us, but it didn't work as well as total automation would for a large laboratory. And so you can kind of think about quality management systems as pulling all of this together into a system that functions well from the beginning all the way to the end. And that's what a quality management system is supposed to do. There's 2 more levels of quality that come forward here. Quality cost management, and that's pretty big for manufacturing, right? Because everything is about cost there. But it has another dimension we'll talk about in a minute. And then the nirvana is total quality management, where you just are exuding quality out of every pore in your body. And we'll talk about how you can have that nirvana. Okay, so going backwards, so instead of up, down, we're going to go down, or up, down. So QC is about process control. QA is, are we meeting the requirements that we set forth? In theory, it should be the requirements our customers and our patients set forth, but we're not quite there. So are we meeting all the requirements that we have, and what do we have in place to do that? The quality management system takes a big leap, and that leap is we're going to improve quality. So it's not just that we're going to not make mistakes, we're going to get better and better and better so there will be fewer opportunities to make those mistakes. And that's what a quality management system should bring you. Quality costs, and I'll show you in the next slide, starts to move you toward preventive thinking. And so we do some preventive thinking, but if you really are good, you're thinking every minute, where can the next error come from? You know, what's it going to be this time, and how can I make that not happen in my laboratory? Now, the cost is kind of a piece of it, but I can tell you there's almost nobody that can cost out their laboratory, the quality piece of it, like they would like to. There may be, the people that probably can do that are not talking about what it is, because it's proprietary to them. And then total quality management is really, your strategic thinking is occupied by quality, and you're thinking about changing your culture. So what's that mean? Well, Forbes did a entire little monograph for the American Society for Quality, and perhaps some of you missed that because you don't look at the American Society for Quality on a daily basis. But somehow or another, in the 15 emails I get from these people every day, one of these was actually useful. And so total quality management is about establishing that culture, which means changing everybody's minds so that everybody you're working with is thinking about quality. So you can go to anyone in the laboratory and say, what are you doing for quality today? And they give you something other than, I'm looking at the Levy-Jennings plot. I'm doing this to improve. Another piece of that is you're advocating for the customer at every level. And so one of the jobs of the medical director of the laboratory is to advocate for the patient, to be the patient's voice, because you're maybe a little bit better connected than the person that's having to deal with an instrument every day. Then bringing the customers forward first. And if you're really good, you start to award or reward your employees around their quality work, not just around productivity, but how are they doing with quality and what kind of rewards can we give people for that? And then you set very big, audacious goals for what you want the quality to be. We want it to be 10 times better next year. Well, it's pretty audacious to go log, but maybe you can, instead of a 5% improvement, your goal might be set at 25% improvement. So you're really trying to push quality, and everybody in the organization is on board. That's why there's very few organizations, manufacturing, service lines, that are really at the pinnacle of total quality management. Okay, so cost of quality works like this. It could be cost of safety. They're both, the curves are exactly the same. There's probably a lot of other curves like this. The better your quality gets, that is, how much better you are in conformance for what you want to do for your customers, then the cost goes down. And it goes down because your defects, your failure costs up here are dropping. So you're spending a bunch of money for rework. You got people that have to do customer service. You have to send Mike out to apologize to people. All that costs money. And so the fewer times you have to do that, the more you save. And then when you add prevention in, that is, you start spending some money to prevent these things from happening, you get the bottom curve. And so the idea would be you put some money into prevention, your defect rate goes down, your total quality cost goes down, and guess what? You have more money at the end of the year. That's the way a factory would think, the way some service industries would think. But your defects are huge there. And I once saw an incredible slide that got lost somewhere on how much GM spends on warranty work every day. And basically the take home was this. The difference in the take home for Toyota versus GM is that warranty work. because Toyota was doing so much less warranty work. They were taking more money home at the end of the day. What's that mean? It means your Toyota price is looking pretty good. And what's that mean? More people buying Toyotas. What's that mean? You're making more money. That's how it works in manufacturing. So what does CMS ask of us in the quality realm? Actually, they ask a lot of us, and I had never really spent much time looking at this. They want you to evaluate your overall quality. They want you to fix your problems. They actually ask you to review those fixes to see if they worked. And that's pretty tough to do for some of us. But they ask for you to do that. And they ask you to prevent defects. And then, of course, they want you to document all of this. And then they divide out your work into 3 domains, which carries throughout quality management systems for the clinical laboratory. Pre-analytic, analytic, post-analytic. Not chemistry, hematology, immunology. Okay? It's pretty important. It's a big difference. Not sections, the processes that happen. Getting a sample, getting the order, getting the sample to the lab, getting it logged in, controlling pre-analytical problems. Then there's analytic, and then there's the post-analytic, getting the results to the right person at the right time, getting them to interpret the results in the right way. So they're asking us to work in all 3 of those domains. And I would maintain that we do really, really well on testing. We do less well, not bad, but less well in the other 2 areas. The CAP will mirror that because they have to incorporate the CLIA regulations into the LAP program. And they add a few things in there and take a few different takes on it, but they want you to have a quality management program, okay? And it has to be implemented as designed. This is a breakthrough, because if you go back and look at standard after standard after standard, what's it say? Do you have a procedure for X? Do you have a policy for Y? That's what the standard says. It doesn't ask if you do it. It just says, do you have it? Here, they're saying, do you have the system, and is it working like you designed it to work? And you got to show that, and you got to review it annually to see if you actually did that and have evidence of that. And then they want your programs to cover all areas of the laboratory. They don't want just a demo project in automated chemistry. They want it in every section of the laboratory, and they want it in all 3 processes as well. And then they want you to identify and evaluate your errors, think about them. There's many, many ways of doing that, from one-offs to capturing those errors and categorizing them and looking at aggregate data at the end of the year and say, which one are we going to tackle next year? And then you have to have a way for concerns to be communicated both from employees and from the patients. And we all, if you've ever had that letter from CAP that says, we got a complaint from one of your patients, you know you don't want those, because it's a lot of work, I can tell you, and a lot of wordsmithing that can take place. Then you have to really ask for your customers, and CAP doesn't necessarily make it patients. It can be your physicians, it can be your nurses, it can be the house staff, but you need to survey them and see how you're doing and be able to document that you've done it. You have to deal with notifications from vendors, and you have to report bad things to the FDA, and almost every quality management system requires that you follow the laws of the land, which you think, okay, well, of course we're going to do that. Not true in every country. And CAP deals with more than just the US country, so you got to follow the rules of the land. And you have to keep a variety of records. There's a few other things that the CAP asks for us. One of them is a self-inspection, and you got to correct those deficiencies. Self-inspections we do, they may be okay. We'll come back and talk about really what the next level of self-inspection is. You have to ensure that records can be passed on if you're lab closes. And then you have to look at the reliability of the patient's results. So all of us, these are principles we all have ingrained in. If we didn't have an LAP program, we would still do all of these, I'm pretty sure all of us would. So what are the key elements of a quality management system? Well, as I already said, one is the continual improvement. So it's not static. You got to get better. You got to show that you're better. So nothing's worse than to be inspecting a laboratory and you see this nice charts in their quality area and everything looks like a Levy-Jennings chart for sodium. It's not going anywhere. Well, the good thing is it's not going down or up, depending on which direction you want. If it's errors, you want it to be going down as opposed to being level. But that's not good, and you have to bring that out in the inspection that your quality indicator is not moving. So maybe you want to think about what you could do to move it one way or another, because it's not doing you any good to plot it the way it is. We talked about analyzing and documenting processes. So the quality management systems are process-based, not department-based, not section-based, around the process. And there's a very logical reason for that. If you think about where errors occur, and this is clear in patient safety as well, they can occur between phlebotomy and processing and chemistry or hematology, and then depending on what happens there, between those areas and resulting. And the weak points are these handoff points. Same way you transfer a patient from one area of the hospital to another, you have a handoff. You know, I don't ever want to be in a handoff for sure, because that's where bad things can happen. That's why if you look at the process, two things happen. One is you're looking at something that doesn't have handoffs, because that's the process you're looking at. The second piece of that is you're focused looking upstream and downstream from what you're doing. Because once you get your analytical piece working well, as they do here in our department, then your problems are going to be upstream and downstream. And so if you look at it process-wise, you can start to say, what are, the client that doesn't send us the right specimen that we need, that we told them they needed to send us, how can we get them to send us the specimen that they need, or give us enough blood in the blood culture bottle so it actually will grow so that they can get an answer that they need. So that's why you do processes. And then you set up an ongoing system that makes all of this work, and you use metrics heavily. And you evaluate those metrics and you act on those metrics. And you monitor the effectiveness of your quality program. And you do that two ways. One is internal assessments. I'm going to come back to that. And the second is external. So the way we do it for CAP is we have 1 year an internal assessment. The next year we have a group of external folks coming in, walking through the lab, taking up our time, and looking very closely with a lot of eyes. Are we doing what the standard asks us to do? Are we doing what we want to be doing? And do we have any other observations that can help the laboratory? So that's how you monitor effectiveness. Okay, so let's come back to quality management systems in the clinical laboratory. So CMS gives us regulations, not a system. The CAP gives us checklists that are not overly broad nor very deep, but they're there and they're making progress. And then you come to some robust quality management systems. And the one, how many people know about ISO 9001? Okay, so within this whole set of standards, industrial standards, is one called 9001, which is the standards for quality management system, i.e. the lowest requirements for you to have a quality management system. They can go up from there, but they can't be below that if you're certified as having that quality management system. Then a derivative of that, closely akin, probably an offspring would be one good way of looking at it, it's probably about an F2 offspring, is ISO 15189, which is specifically for the clinical laboratory and specifically deals with quality and competence. And then the Clinical Lab Standard Institute has made great inroads. Remember, CLSI is the guys that bring us those blue books. Does everybody know about the blue books, right? And you know, sometimes you don't want to follow the guidelines. You don't have to. Sometimes you think they're pretty wordy, but that's another quality management system we'll talk about. Then FDA has a whole regulatory system in and around good laboratory practices, and there's many others that touch us peripherally in the clinical laboratory. So, ISO 9001, International Standards Organization, the key word is international. You get a bunch of countries all operating with a bunch of different languages, producing a document in 3 languages, so wordsmithing is really right up front there. Many, many standards, so if you look at how many documents they have, is 40 screens worth on the font that I use on my screen. And it's, you know, steadfastness of dies. It's very exciting stuff, and some of you will want to look at that. But the one we're talking about is for a quality management system, and is to provide an element of confidence for service industry or company. Actually, anybody can use it, but it gives you a level of confidence that someone has built a system that adheres to this set of standards, and that someone from outside has come in and certified that and said, yes, you do. That set of standards is fairly different than the CAP standards. They're very less prescriptive. It's, instead of doing controls twice a day, it might be the old CAP way of saying you need to control this process. And you get to decide how to do it. But once you decide how to do it, you got to do it the way you decided to do it. You can't just say, well, we're going to change our mind about this. You wrote it down, you got to do it that way. And so is this thing really important or not? Well, if you drive around other countries, you look around, you'll see this on the sides of factories. And I got somebody who was out in the boondocks of Costa Rica to farm, and the farm had ISO 9001 on it. They were certifying eggs. I don't know what they were certifying, but they had a quality management system for whatever the farm produced there. I'm not sure if we have any marijuana farms in the state that are ISO 9001 certified, but I'm sure that's coming. And I'm looking for some consultation. But anyway, so does it have an effect? So here's the deal. Looking at companies before they were ISO certified and after, an aggregate group of companies, 9% increase in sales, growth by 18%, wage increase by 8%. So something's happening to those companies. Okay, yeah, everybody's a scientist here, and they say, well, maybe they were just better to begin with, and they selected to do this. That's true, but you still got some performance correlation there with it. Okay, now for those of you that want to move forward and really get into ISO 9001, there's many, many books. And I can't suggest any particular one of these. For the cheapskates in the audience, you actually can probably go to Amazon, look inside each one of these, and probably end up with a whole book, just depending on what they give you to look inside on each different book. So give that a try. I can tell you, these are tough readings. And I've read one of these so many times, and every time I read it, there's more that comes out of it. And you really want to move, and it's not the one for dummies. I just want to mention that. It's one of these other ones, okay? Okay, so what's the philosophy? Now, our hospital made a big leap about 2 years ago and dumped the Joint Commission. And they dumped the Joint Commission because they felt like that did not prepare us to get better. That every 3 years we ran around getting ready for an inspection, and we were never ready. And we just hoped they didn't find our problems. So decided to take a different tact and go with Der Norske Veritas. who has been in the maritime industry and has done all kinds of accreditation throughout the world. And their accreditation for hospitals is we accredit you to the CMS standards, and you have to be ISO 9001 compliant. You have to have a quality management system that meets these minimal requirements. And their philosophy is reflected here. And it's, it's pretty simple, right? You think about what you're going to do with a lot of thought, then you write it down, you train everybody to do it, you keep making sure you're doing it by data and audits, we'll come back to that, and when you have a defect, you don't do it, you figure out why, and you try to fix it. And then you improve and you improve and you improve, and then once a year or so, you review the whole thing and say, well, how can we get better? I mean, this is something all of us want to do. This is mom and apple pie. And the webinar says it perhaps better than I have. So, coming back again, 8 principles of ISO 9001. Customer first. It's right there. Customer. What's your customer want? What are you doing for your customers? How do you know you're doing the right thing for your customers? Absolutely critical. You say, well, does that make a difference? It's interesting. It doesn't make as big a difference as I think it ought to, but if you look at world-class institutions, I know how it's defined, the business people define world-class. We define ourselves here as world-class, that's for sure. And 70% of the CEOs of those companies said, our quality program is driven by the customer. Versus non-world-class, where only 50% of the individuals said that. So it's not the best numbers. Statistically significant. You'd like for them to be a little bit better, but at least world-class institutions are looking at customers driving their quality. Leadership is key, because if your leaders aren't on board, this isn't going to happen. So you have to have the leaders committing to quality. But it's more important than that, is you have to have all your people there. So when an assessor goes into your organization, they're having a sit down with the leadership. Where are you on this? And if the leaders say, I don't know, talk to our quality guy, I don't know anything about this, bammo, they're probably not going to be certified. When they go to the front line people and say, what are you doing for quality? They say, we don't do anything for quality around here. Everything just sucks. They're not going to get certified. It needs to be articulated top to bottom. And that's a piece of getting toward the cultural change. Process approach, we already talked about that. A systems approach to management, so building a system. Continual improvement, a factual approach to decision making as opposed to one person just saying, we're going to do it this way. What's the data? Show me the data. Fits really, really well with what we do in laboratory medicine. And then something that's a little different, mutual beneficial supplier relationships. This is a tough area. It's much easier when you're a company and you're buying supplies. We're further away maybe than buying supplies. But every time we've tried to talk to the suppliers about we're your partner, we're your good partner, and we have to tell you that you suck. But we're your partner, and we're stuck with you, to be truthful, and we want you to get better. And we've written some contracts with performance characteristics on manufacturer's quality in them, and we're holding the suppliers to it. And lo and behold, our last one just made their breakthrough, and they cut their error rate in half. Whether they did it for that contract or they didn't want to talk to me, one of the two. But it's that partnership piece that you're really working on. Now, of course, when we get on allocation for supply, what do we say? Back to them, we're your best partner. Okay? We're not just a partner, we're your best partner, so we want the shipments to come here. We don't care about the other hospitals, make sure we get what we need. So that's is what ISO in principle asks for you. Kind of works like this. Okay? So you establish a system at the top, and in that you have some contract reviews and some design controls and management responsibilities. And then you have controls built around all of these processes that contribute to your quality plan. So document control is one of those. You can't very well make sure that people are doing the right thing if they're reading a document from 3 years ago that's now obsolete. They're going to be doing the wrong thing if they follow those instructions, right? That's why you have document control for one. Equipment control, dealing with your errors, a regular process control, and then you do a review. And you do those reviews in a couple ways. We already talked about some statistical reviews and some audits. And then you say what's not working, and you improve it, and you go to another cycle. All of you will recognize this as clear-cut PlanDoCheckAct. It's no different, and it's actually the simplification, really, of ISO 9001. There's nothing really new in this. It's just pulling it together. And we all are working in the PlanDoCheckAct cycles. Okay, now, so this is one area that deserves a touch of talk. So the review process is this auditing. So not just the outside inspectors, but the inside inspectors. You auditing yourself. Do we do that? Yeah, we do that. We're doing that every day in a variety of fashion. We have supervisors looking over people's shoulders, managers looking there. We've got faculty looking. So we're kind of doing some auditing. But what's ISO 9001 asking you for your audits? Something actually a whole lot more. That you plan them. You know who you're going to audit, what you're going to audit, when you're going to audit. You have a plan there. And you're going to audit not the process control, the analytical piece. You're auditing this quality management system. Is it functioning? Is it picking up the defects you want it to pick up? And if we're picking them up, are we doing something with them? Or are they just sitting there? You know, yeah, we had 25 defects yesterday that we're not doing anything about. So the audit can be strenuous. It is required that you audit outside your area. So within the laboratory, that means a hematologist is not going to audit hematology. You're going to have somebody that doesn't know anything about hematology, but knows about auditing hematology, for example. And that's to give you some degree of objectiveness. And then you have to, within the auditing process, you will have findings, and you will have corrective actions that come from those findings, and then you have to be able to demonstrate that your fix actually worked. And usually that's done with metrics, and that's actually pretty tough. So that's the Check Act. Now, there are opportunities for laboratorians in ISO 9001, and some of you may be tapped to work on quality systems, and I know you're getting excited. I can just tell from the smiles on your faces already how excited people are about this. Anyway, let's go on to CLSI. So the blue books, there's one for almost everything in the laboratory, but some of you may not have seen the blue books on the quality management system, and they're actually very, very good. There's a lot of good writing, there's a lot of explanation, there's great diagrams. I've stolen many for this talk. There's appendices that kind of say, well, if you want to do this, here's some examples of how you can do it. And they touch really not yet all the areas of quality management system. They're quality essentials, but most of them so far, including auditing and non-conforming events and document control. And this is kind of their diagram of how they put it together. So sections up on the left, they're just kind of hanging there. It's really that process, pre-analytic, analytic, post-analytic. And then their quality essentials. So assessments, continual improvement, customers, all the words you've already heard. There's nothing really new here. It's really the same concepts done a little bit different way. And if you look at that, it's very nice. So you got the same principles that we had in ISO 9001. Okay, so that brings us to the CAP and what they have decided to do about this. So in 2008, they began to certify laboratories to this international standard for clinical or medical laboratories, 15189. And this program continues to march on. I'm on the committee for it, and that's why I was able to actually steal these slides from colleagues there. There are other agencies worldwide that do this. So for example, in China, they use ISO 15189 as their lab accrediting process. And a lot of other countries do that as well. There are over 30 labs in the program with the CAP right now, and actually a much larger number in the pipeline for that. Some of those are outside the country. They're multinational labs, and many of them are large reference laboratories whose names you know, and they're actually on the website, the CAP's website. The CAP requires that you are LAP accredited to begin with. They did not want to start with a competing program, but two, they wanted to have a level of quality already in a laboratory before they went in to add this program. There are a lot of educational webinars. I think there's 6 or 7 now that are very good that one can subscribe to. And they have 5 professional assessors and 1 committee. And it takes a while to get there, even for a mature laboratory. So kind of what's the difference? Well, we have peer inspections for CAP. We have professional inspectors for the 15189. The accreditation or LAP is procedurally based, whereas 15189 is really going beyond the laboratory into pre and post analytical, supply chain, and really moving into preventive work when it's possible. Voluntary in the US, some countries require this, but 15189 is voluntary, and we don't think that's going to change. We think the elements are likely to be incorporated slowly into the CMS because they want to increase the quality of the laboratories. The goal of 15189 is to make a failure-resistant system, whereas LAP is to make sure that you have good, valid, current practices. And that's pretty much the difference. And CAP is lab-focused, and LAP is lab-focused. 15189 requires you stepping out more broadly, as I said. Okay, now, been flying way up here over the Earth at a high, pretty big height. And I'm going to avoid Roswell and get down to Area 51. I'm going to take you down just for a quick look at what the different standards are, okay? But it's just going to be one quick look. So here they are. And luckily they're small enough that some of you can continue sleeping rather than actually reading these. But on the left are the quality management system principles, and they are pretty much the ones I've been talking about. Why? Because they were taken from 9001. So it's pretty much the same things. The one piece that's a little different in here is actually 15189 requires root cause analysis, and 9001 does not. Then there's a technical piece, and the technical piece could be called CAP Light or LAP Light. It's really just another look at what's happening technically in your laboratory. It's not the same standards, it's a different look, but it's focusing much more around, it's process-based, but it's really focusing around the output of the laboratory. So those two coming together, along with LAP, we think would make a lab stronger, more competitive, more cost-effective. It's tough to prove that. We have one laboratory that's reported since they've been 15189 accredited that their cost has dropped 4.7%. The problem with that, and with every cost analysis around an event, is that's not the only thing that's happening in the laboratory. There's lots of other things, and it's true at the hospital level as well. We cannot cost 9001 at the hospital level. We can just hope that it will save us money in the long run and give the patients a better experience. And so there's it's kind of a faith-based quality management system, if you will. And if anybody has any ideas on how you could prove it, I think our committee would be very interested in that. So the process works like this. You make an application, and then somebody looks at all your, how you've been doing on your proficiency testing. What kind of policies do you have now? What's your procedures look like? What's your document control look like? So there's a desk assessment just from the paperwork. And then you have a gap assessment where assessor comes in and really does not a mock inspection, but pretty much inspection, says, here's where you're doing well, here's where you're not doing well, you really got to work on this. And you have a period of time to work on that. And then they come back for a pre-assessment look, looking harder and tighter and saying, okay, here's the 15 things we found. You got to fix these defects and you need to do this, this, this also. And then you come back for your real inspection. And if you have deficiencies, you have to correct those before you actually will be accredited. And then the next year you get another inspection, the next year you get another inspection, and the third year you get recertified with another inspection. So it's an annual inspection process. There are some new areas for the laboratory. We talked about internal audits and root cause analysis. Corrective action is a little new for some of us, as is preventive action, the process mapping. The continuous improvement, if you can't show it, we know we're doing it, but you got to really be able to show that. And a very rigorous management review. The new edition of 15189 incorporates a topic that makes the rest of this look like easy reading, and that's the uncertainty of measurement. And don't go there, that's all I can tell you. And we figured out how to make it reasonably easy, and then risk assessment. But uncertainty of measurement, there are people that spend their lives on that. Okay, so the good news is for laboratorians, we actually have a lot of ways that you can get better, because the CLSI Quality System Essentials maps right on to ISO 15189. So they really are, it's not two different, and there are two different ideas, two different systems, but if you've done one, you're ready for the other if you want that, or you don't have to do it. But you can look at both those systems for ways that you can make your laboratory better. Okay, so I've talked about factories, and I've talked about service industry and high output, just like our analytical areas of laboratory. And all this works well for that. But there's another dimension to what we do in the laboratory, and that's our intellectual piecework. At least, hopefully everybody in here is doing some intellectual piecework, right? If you're not, we can talk afterwards. And that really is not susceptible to many of these control mechanisms or even improvement mechanisms. I mean, what are you going to have, a Levy-Jennings plot on how you interpret the colonies on a plate? I don't think so. So what do you do about that? Well, you have to there's production work and what I call craft work. And the craft work is intrinsically different, and how you deal with that quality is intrinsically different as well. So production work, you train everybody for a certain standard to make a certain widget each time. Back in the cuckoo clock factory with 2 people, you train one person for 10 years so they can make a cuckoo clock just as good as the master. Okay? That's the way it goes. But that's kind of how we do it on some of our intellectual interpretive skills as well. So very person dependent, and that changes things. Production quality gets systems. And systems, to the extent that we don't build them perfectly, they give you a lot of mistakes. Okay? And you have to fix the system, not the people. Craft work is usually not the system, it's the people. Okay, so flow cytometry would be an example. In histology, in anatomic pathology and anatomic hematology, you have production as a piece, and then there's this craft work in the middle, and then you have production on the back end as well. So it's kind of both systems going at once. You say, well, there's no problem with craft work. So in the archives, one of the Q probes came out. So you vary in the labs that participated, who we might think are better labs because they participated to begin with, error rates from 1 to 13 per 1,000 reports. Okay, that's a pretty healthy error rate. And within that, over on the left side, you can't see, it's about a 15% rate of misinterpretation. And then it goes down with a variety of others, including typos. But there is a finite, measurable error rate amongst laboratories in craftwork. Now, our hospital also has been having a lot of initiatives around patient safety. They've engaged a company called HPI, and a piece of that is the taxonomy of errors. And one of those is system errors, and the other is, if you will, individual errors. Okay? And so you've got these different domains, and over on the right is compliance. That is, you're just a bad actor, and we don't really have that problem. We have these other problems I've starred, and the ones in red are the ones I think I see a lot. Tunnel vision, I'm not thinking as broadly as I should, and my mindset, I've already decided what I'm going to say about this case, and it doesn't matter what the evidence is, this is what I've decided about the case, and I can't shake off that mindset. Perseveration of first look or first hearing is kind of how that starts out. And so there's a lot of different ways you can have these errors. So now we get to the audience interaction. What you have to do is close your eyes, and you got to trust me on this, and the camera can't focus on anybody. The camera has to stay on me. So everybody close their eyes, and what I'm going to ask you to do is, if you've had this problem, just raise your hand and keep it up. Okay? But keep your eyes closed because we don't want to, well, Pete was ahead of the game on this, but yeah, so just close your eyes. Here we go. So lapse, overlooking a finding on an exam. Okay? And you got to raise them high. Tunnel vision, preservation of the first thing. I'm going to keep my eyes down too. So, okay. Inadequate knowledge, you didn't do a search on Google. Compliance with patient identification, talking to someone about the wrong case. I've saved myself a couple times on that. Squeezing things into the wrong category, particularly into a sexy category. It's terrible. Interruptions, somebody calls you in the middle of the case and you pick up where you left off. Shortcuts. He said, I don't need to spend the money for this. This is okay. I don't need to do another test. Failure to validate. I'm pretty sure, but I'm not going to show it to somebody else. I'm not going to put it aside and come back and look at it tomorrow when I'm fresh. Lack of experience. Shouldn't happen for some of us in this room. Indifference. Failure to pursue the case to endpoint. Sometimes that gets me when I'm trying to get out the door on Friday. Habit or reflex, you fail to ask for more specimen because you're going to make somebody mad by saying, why don't you submit another swab on this patient? Overconfident, usually we weed those people out pretty quickly if they have that problem continuously. Situational awareness, knowing how important this little biopsy is to you, and that you could be making a bad mistake because over on one side of it is the clue to the diagnosis if you only knew more information. In compliance with patient identification, you picked up and didn't match something that you were looking at with the piece of paper and you got mixed up on the patients. Now, close your eyes again, and if you made any of these mistakes, raise your hand. So I'm going to report. Okay, so there's some people are lying, but we've got well over 3/4 of the people there that have been down that route. So what do you do about this? So there's some ways. You select the right people to begin with, and everybody knows that's key. In anatomic pathology, I actually think colocalization is incredible. It works for us very well so that if I need to show something to someone, they are 5 feet away, and there's no inhibition. Other than the fact they don't want me in their office, there's no inhibition to showing a slide to someone. National meetings and reality checks, proficiency testing, outside consults will tell you, have you drifted? Have you drifted as a group? Are we matching everybody else in the country like we ought to? Clinical conferences, so our clinicians can tell us we've messed up, that no, this really isn't right, and when you have interruptions, starting over from the get-go so that you don't make a mistake. And then having a blame-free environment is really key so that you can share these mistakes and the near hits with each other. So what's the take home here? One, quality control, I think we've achieved pretty close to where we want to be in that. And for quality assurance, we need to be addressing pre and post analytical concerns a little bit more. But if you're going to move to the next level and sustain what you're doing, you really have to consider a quality management system, or at least the components of that. We have to interact more with our customers. Of course, we're going to be giving them results directly eventually, and we probably will have a lot more feedback and interaction with them. And then human factor engineering can come into play for us. So with that, are there some questions, comments?